Hi there and welcome to this month's video blog post from Spicule. This month we're going to look at how to deploy this and combine it with this, nope, sorry, wrong picture, this one, using the Juju application modeling platform. So just what is Kubernetes? Kubernetes is a container orchestration and scheduler originally written by Google and then open sourced. It is currently leading the container orchestration battle because for the last few years, Docker has been on the rise, and it's finally got to a point of maturity where companies want to be able to roll this stuff out across their data center, but don't want to necessarily think too much about how to deploy it onto deploy their containers onto individual servers, and instead just want to care about deploying their code across their data center as a single entity. Because of the fault tolerance and scaling capabilities built into Kubernetes, it gives far better elasticity than running a traditional Docker run would. If you run Docker run, it would deploy a container to a single host, but it doesn't allow for fault tolerance. If that host disappears, so does your code. So Kubernetes obviously abstracts that away and gives data center deployments an additional level of stability, which generally makes system administrators quite happy. The problem is with Kubernetes is it's quite hard to deploy. There's a lot of moving parts. There's 3 or 4 different components that make up a Kubernetes deployment. And so what we're going to look at in this tutorial, in this blog, is the ability to be able to deploy that stuff using the Juju application modeling platform to control the deployment of the Kubernetes services across the cluster that you want to run them on. For those of you who don't know, Juju is an application modeling tool that was developed by Canonical, the guys that make Ubuntu, and it is there to allow you to deploy big data, big systems, complex systems to different servers without having to worry too much about how the configuration works and how it all hangs together. The idea being that the charms, the code that encapsulates the software, allows for relations and metadata to flow between the different bits of code, and this then allows you to deploy large software on distributed servers, not single servers, and not containerized, in a bunch of different places. So you can deploy it to AWS, you can deploy it to GCE, Joyent, bare metal, or just to local LXD containers, which aids development and the deployment of test loads. So without further ado, let's dive into the code and get started. Okay then, so we're going to take a look at Juju and how we're going to deploy our Kubernetes stack into, in this case, AWS. It doesn't have to be AWS, of course. It could be into your own infrastructure environment. It could be a different cloud provider, or it could be locally on my laptop if I really wanted to test it that way. But for ease of demonstration, we're going to deploy it into AWS. So to get started, I have a Linux laptop here, and I'm running Juju 2.1 beta 4, which is, I think, slightly out of date, but you know, it does the job. And so to get started, we're going to have to bootstrap Juju. Bootstrapping involves it creating a controller node, which again is a cloud instance or a virtual machine or something that allows Juju to communicate with the rest of the cloud services to control controllers, models, users, credentials, all that type of stuff. It's all dealt with from the bootstrap node, from the controller node. So to get going, we're going to do Juju bootstrap AWS, and we'll call it my K8's cloud. So you can see that the controller is then starting to come up. I've already got my credentials persisted within the Juju client, so it can go straight to AWS and tell it to start spinning up nodes. And so you can see that it's defined a 4 gig 2 core instance and is now spinning up Juju, fetching the Juju GUI, which we'll get onto later, and we'll now sit here and wait for a little while until the the VM comes to life, at which point Juju will be bootstrapped and good to go. Okay, so the Juju controller has been bootstrapped. As you can see, my prompt has returned, and I can now continue on my merry way deploying the canonical Kubernetes distribution to my Juju stack. So if I do Juju status, I can see that I have nothing in my controller because obviously I've not deployed anything to it. And so we're going to get started. And to do that, we're going to Juju deploy canonical Kubernetes. You could do this using Juju GUI, but I'm a command line guy. And obviously, this allows you to see how easy it is to be able to spin up stuff, and you can script this going forward as well. So you could wrap all this in a bash script and have it done automatically by a service spinning up remotely. Okay, so canonical Kubernetes is a bundle. A bundle is a collection of charms. A charm is the wrapping that goes around an application that you want deployed to the Juju ecosystem. And so you can see how it's located the bundle, it's downloading the metadata, and it's now pumping that up to the controller node, asking for its resources and figuring out exactly where it's going to deploy this stuff. So as that runs through, you can see that the deploy the bundle is now completed. So now going back to Juju status, you can now see that obviously the status has changed quite a lot. And it's now waiting for EC2 nodes to come to life to be able to deploy this canonical Kubernetes distribution to the platform. So instead of just running that time and time again, I can do watch Juju status, and you can see in the DNS for the machines, you can see they're getting allocated. So obviously the machines are coming to life. Once the machines come to life, Juju can then assign them to a specific unit. The unit will then download the Juju charm to it, various other bits and pieces that it needs, run apt-get update, that type of thing to get the system as current as possible. And then we'll install whatever software has been defined for that unit onto the agent itself, onto the node, which will then obviously load up the Kubernetes cluster. The relations that run between the different units will take some time to configure. Obviously, they rely on different units to come to life. And so when all the units are up and running and they've registered themselves, the cluster will then go ahead and configure its own metadata, meaning that we don't actually have to interact with it to get it set up and running. And so we'll leave this for a few minutes, and then when we come back, we'll have a running Kubernetes cluster. Okay then, so you can see now, if you look at the screen, you can see how the Kubernetes system has been started. Everything's green, which is good. we have a bunch of different services and a bunch of different units. If you look at the unit section, just highlight here, you can see how we've got easy RSA, we've got etcd, we've got kube controls load balancer, we've got one Kubernetes master and 3 Kubernetes workers. Now the cool thing about Juju is its scalability. So if we want more workers, we can do Juju add unit. You could specify an amount, but I just want one. So we could do Kubernetes worker, and there we go. And so if I go back to look at my status now, you can see how we have another worker that's allocating, and scaling services is pretty much as easy as that. You know, you can define constraints for machine sizes, but adding new machines to do more processing is as simple as Juju add unit. And if you want to scale back down because you've gone past the peak cycle of load, then you can do Juju remove unit, and the unit will go away, and you're back to where you were. So it's very flexible in the way that you can deploy your Kubernetes cluster, and you can obviously scale up and down according to load, and just figure out what works for you. So now we're going to interact with Kubernetes a little bit. So if I paste this script, not that script, this script. If I paste this, you can see how we've made a local kube directory. We've now SCP'd the configuration down to the local host. We're in the process of downloading the kube control binary, because obviously I don't have any Kubernetes stuff installed locally, and rather than having to go and compile my own binary for interaction with my cluster, it's quite convenient to obviously be able to just like SCP the binary for kube control down to your local machine. There is the caveat that you have to be able to run on the same architecture as it's deployed to, but other than that, you know, I'm running a Linux laptop, they're on Linux servers, so I'm pretty much good to go. Once that's downloaded, we will then just execute a quick query against the cluster and just make sure that we are up and running, and then we'll look at elk. So as you can see, I've run kube control cluster info because my kube control executable has been downloaded, and now we're interested in making sure that the cluster is up and running and everything is healthy like the Juju status says it is. So as you can see, the cluster info returns a bunch of information, URLs for different services that are running. We're not particularly interested in them, but one thing we are interested in for ease of interaction and visibility is the kube control dashboard. And so if I go to my browser and look at 8001 UI, because the proxy is running and effectively we proxy into our cluster, I get instant access to the dashboards that Kubernetes supplies. So I can see, you know, obviously the CPU usage on the cluster, the memory usage on the cluster, what's running, what isn't running, you know, the stuff that I would have expected to have been deployed within my my configuration, my setup. So, you know, we've got that deployed, and now we're going to have a look at how we can enhance the logging more effectively by using the elk stack, and getting the logging out of Kubernetes and into elk for further processing. Okay then, so we have our Kubernetes cluster deployed, and part of what we want to do today is look at how we can extend and improve the logging coming out of the system to give developers and system administrators better oversight over the software they have deployed. So one way to do that is to use the elk stack, which is Elasticsearch, Logstash, and Kibana. And Juju has great support for the elk stack, and it will allow us to provide streaming logging coming out of the various units into our Kibana, into our Elasticsearch and Logstash deployment, which will allow the system administrators quick access to dashboards, charts about the load, and the various bits of information that provides. Of course, Elasticsearch isn't necessarily the only way you could do it. There's also very good support for Nagios. So you can deploy a Nagios server for your monitoring and alerting, and then you could use Elk for the logging and getting the low level stuff out at line level. But we're going to concentrate on the Elk stack today. So to get started, we're going to deploy Beats, which is the topology for the Elk stack to be able to talk to the different containers. And so you can see how I've deployed a bundle called Beats Core. Beats Core ships with Elasticsearch, Kibana, FileBeat and TopBeat. We also deploy slightly different FileBeats and TopBeats for the Xenial operating system. And then we go ahead and just correct that one. Relate the different containers and charms to each other. So one thing we haven't looked at is Juju GUI, and so if I flick over to Juju GUI, when it loads, Juju GUI is a great way for you to be able to visualize what's going on within your stack and what's deployed, and it's something that allows people who have a stake in what's deployed to be able to understand quickly without having to look up diagrams or ask for in-depth description. You can quickly and easily see exactly what's deployed within your Juju cluster, and you don't have to be technically minded. Of course, a project manager can have a look at this and quickly understand what they have deployed in terms of processing and compute resource inside their AWS cluster or whatever. So on the left-hand side, you can see how we've got the charms. Each round circle is a charm. It might hold more than one unit, but at a low level, it's a charm. And on the left-hand side is the Kubernetes stuff. And so you can see how there's the Kubernetes load balancer, the various workers that we have deployed, a single master, Flannel, etcd. It's the full stack encapsulated and displayed graphically on a screen, which is great. And if I want to make changes and configure it without having to drop down to the command line, then I can do that, which again is a way for end users to be able to tweak what's deployed without them actually having to have a Juju client installed or being particularly technically minded. They need to know what to change, but they don't necessarily have to understand how a bash script works or how to change a configuration file in the etc folder, whatever. They can just tweak some bits and pieces on the dashboard. So there's some configuration options, and then on the right hand side you can see the various charms that are available for Beats. And so I've got my Elasticsearch charm. You can see that it's pending. Oops, it's just gone green. And so I've got Elasticsearch, Kibana, and then my different Beats which provide different services to them for access. And so if I flip back here and have a look at Juju status, you can see it's pretty much there. We're just waiting for Elasticsearch to go green and we should be good to go. So if I do Juju expose Kibana, by default the firewalls for all the services are closed. We don't want prying eyes getting in, but we can do Juju expose and it will open a firewall port for the charm that's been deployed. So I know Kibana is running on port 80, so if I flip back to my browser and go there in a couple of seconds. So I've got a basic Kibana instance. I know there's a more modern version of the Elk stack that's coming to Juju in the not too distant future, but for the moment we've got version 4, and there's nothing deployed to it. So what I need to do is load my dashboard. So Kibana 1. So if I load the dashboard, this runs an action on the server, and so action is like a pre-canned command that you can pass in parameters for. So in this case, it's load my dashboard. The dashboard is called Beats. And so that will queue up. And with a bit of luck, when I refresh, you can see how I've now got these index patterns on the left-hand side. And so from that, I want to pick, I don't know, TopBeat as my default. So I select TopBeat and then flick over to the Discover section. And you can see how already in next to no time we have a bunch of logging information coming into the platform. And so that logging information is available to the administrators as a way to be able to debug what's going on. But of course, end user logs aren't the most effective way of being able to see at a high level what's going on, even though they might provide the raw information that you actually require. So Kibana has very good visualizations, and so a lot of them come pre-canned. And so if I want to know the CPU usage, I can quickly open a chart that shows me the CPU usage. And if this was over a stack of 100 servers, suddenly it would provide an awful lot more information quickly and easily in one snapshot than me having to look at individual servers one by one, or have to wait for triggers to come up high to tell me that something's running over the top. So similarly, I could have a look at disk usage. I can examine the disks all from within my web browser. And so, ELK provides that oversight and that ability to be able to probe system information coming straight out of your Kubernetes cluster, at a few clicks of a mouse. So hopefully you found that tutorial useful. Being able to deploy a complex piece of software like Kubernetes so easily using a tool like Juju is absolutely a system administrator's dream. It makes our lives so much easier. It allows us to concentrate more on doing the cool stuff instead of the repetitive work that we would do otherwise. Obviously, leveraging the extended capabilities of using the ELK stack to deploy highly available logging, to be able to see what's going on the hardware. Still not using any code, just leveraging the relations that Juju offers in the platform itself to combine those two platforms together. Just allows us to scale that software and that deployment quite quickly and easily without adding the complexity of extended configuration files and stuff like when servers go missing, the IP address is changing, those things keeping in sync with one another. So anyway, I hope you enjoyed it. Swing back for more blogs, video blogs and information over the coming weeks. We'll have some stuff coming up with DCOS, which is another container orchestration platform, some more Juju stuff. We'll go through charm writing, the whole works. And so I hope you can join us again soon. Bye for now.